We are on lesson 13. Our objective says, I will be able to calculate and compare square roots using knowledge of perfect squares, estimation, and radicals. So, first thing we need to review before we start are perfect squares. Perfect square is a number that is the square of an integer. The product of an integer in itself is a perfect square. So 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square. A square root is indicated by a symbol like this. A radicand is the number or expression under the radical. So here, 50 is the radicand. Here, 7 is the radicand. This symbol right here is called a radical. So that's a radical symbol. The number under the square root sign, or under the radical, is the radicand. The square root of x, written square root of x, is the number whose square is x. So when you take the square root of 16, the square root of 16 is 4. The square root of 16 is 4 because 4 times 4 gives me 16. A square number can only end with the digits 0, 1, 4, 5, 6, and 9. However, not all numbers ending in these digits will be perfect squares. So remember, a perfect square is a number under this radical sign that has a number when you multiply it by itself gives you the number under the radical sign. So, is the radicand, radical 50, a perfect square? So what that's asking is there any number that when you multiply it by itself, it gives you 50? Well, let's think. I know that radical 50 is not a perfect square. Okay? How do I know that? Because I know that, well, 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. So I just passed 50. Okay? 50 is between 49 and 64. So if this 50 right here does not, when you have a number multiplied by itself, when it does not give you that 50, that lets you know that 50 is not a perfect square. But I know that radical 50 is between this perfect square 49 and this perfect square 64. So, well, actually, no. We're going to leave it at that. Later, it's going to tell us to estimate. But all I need to know right now is that radical 50 is not a square because radical 50 is between radical 49 and radical 64. The square root of 49 we know is 7. The square root of 64 we know is 8. Okay, what about 64? Is the radicand 64 a perfect square? Yes. The square root of 64 is 8 because 8 times 8 gives me 64. Okay? When a number multiplied by itself gives you the number underneath the radical, or gives you the radicand, which is this number right here, then you know that number is a perfect square. Now we remember, example A here, ask us about radical 50. This next question is also going to ask us about radical 50. It says, estimate the value of radical 50 to the nearest integer and explain your reasoning. Okay, well in the last problem what we figured out is that radical 50 is between radical 49 and radical 64. Okay, remember radical is just the same thing as saying square root. Okay, so 50, is that closer to 49 or is it closer to 64? Well, it's only 1 away from 49, so the approximate value of 50 of radical 50 is going to be close to whatever radical 49 is. So what's the square root of 49? Well, that's 7. So radical 50 is approximately 7 because it's approximately 7 because the value of radical 50 is close to the value radical 49. And we know radical 49 is 7 because 7 times 7 gives me 49. So one last thing we want to put is that 50 is closer, that's a 50 right there, looks like so. 50 is closer to 49 than 64, right? It's only 1 away from 49, and it is 14 away from 64. So we know that it's closer to 7 than the square root of 64, which is 8. So make sure we got all of that down. 50 is closer to 49 than 64. Last thing, so to compare the expressions, use less than, greater than, or equal to. Alright, so what I've got here, remember our order of operations. Grouping symbols, exponents, that's 2 E's. Grouping symbols, exponents, multiplication, division, addition, subtraction. When we talked about exponents, we said it wasn't just exponents, but exponents and roots. So when we are simplifying this, what I see is that I've got addition and I've got roots. So, we don't have any grouping symbols here. We do have an exponent or a root, so we need to do those roots before we do this addition. So we take the square root of 4, which is 2. We take the square root of 36, which is 6. Alright, we want to go ahead and evaluate this. 2 plus 6 is 8. Then we want to evaluate this side. Square root of 9 is 3. Square root of 25 is 5. 3 plus 5 is 8. So 8 is equal to 8. Answer here is an equal sign. That is it for lesson 13.